Okay, here at the beginning we do all sorts of silly examples like this to show you sort of the power of this dimensional analysis. And you won't, beyond this first chapter, do anything like this. But later, when we're doing things like stoichiometry, you'll see the power of this dimensional analysis. Also, I always like to teach dimensional analysis at the beginning because it's very useful in a whole range of majors, a whole range of occupations that you could have in the future. For example, in finance, if you look at the derivatives market in finance, dimensional analysis is very useful. It's useful in nursing and a lot of other places. Dimensional analysis can be used. And so, we'll ask some weird questions here at the beginning, but hopefully it's more useful for you later. So given the average distance between the Earth and the Sun is 150 million kilometers, and that the speed of light is 300 million meters per second, how many minutes does it take from light from the sun to reach the Earth? Okay, so you want to reach into one of these dimensional analysis problems and see what the data is, and maybe circle it. Taking it on exam, you would write it down. And if you don't know where to get started on one of these types of problems, if you don't know where to get started, you may want to go on the other end of it and look and see. So how many minutes, and see what unit you're looking for at the very end. Okay, we're looking for some number of minutes. And to get to minutes, we're going to have to get there from time. And this guy right here has a time unit in it, meters per second. So I think I can get from seconds to minutes. And so this is probably pretty close to this side. Another way to analyze these kind of problems is usually if you have something that has a single unit, so this is just kilometers, this one's meters per second, this is going to be the starting point usually. Almost always for these type of problems, that will be your starting point. And it is in this case. So 150 million kilometers. We got kilometers and meters here. So I need to do 1 kilometer is equal to 1,000 meters, so that now this can get its hooks into that number. Kilometers, kilometers. Okay, so now I can actually expand this guy. So 300 million meters, 1 second. That's what that unit actually says. Okay, the light is traveling 300 million meters in 1 second. All right, so I'm almost there. Meters cancels meters. If I stop right now, I'd know the seconds, and 60 seconds in 1 minute will give me a final answer here that has the units that I need it to have. Units of minutes. Oh, didn't mean to cancel my minute. Sorry, minute. Cancel my seconds. Okay, and again, I'll show you guys how I would put this into the calculator, if I can get everything on screen. So parentheses, and I would do everything on top. 150, 0, 0, 0, 0, 0, 0 times 1,000. Okay, I'm not going to do the times ones because those don't do anything. Divided by 300, 0, 0, 0, 0, 0, 0 times 60. Close parentheses. Okay, 8.3 minutes. Okay, if you really wanted to get fancy, you could figure out how many seconds was the 0.3 minutes, but I don't particularly care since I asked you to give this to me in minutes. So 8.3 minutes.